Welcome to today's gas solve. Today we're looking at a puzzle called a killer teacher. I wonder if that's a teacher of a killer Sudoku, or a teacher who is a killer, or a really good teacher. Perhaps all three of them, but actually I hope not the second one, if full deck and missing a few cards is my teacher. I've been really enjoying these guys. They make some awesome puzzles. Link is in the description. The rules are as follows: standard Sudoku rules, which I won't explain, and you have killer cages. And cages contain digits which don't repeat and must sum to the value shown in the upper left corner. Cages are denoted by dashed black lines. Let's go. Okay, so this 4 cannot be made of two 2s because that would break Sudoku rules and the killer rules, so it has to be a 1 and a 3 in some order. Similarly in this corner, nice and symmetric. Now this 5 could either be 1 or 4 or 2 and 3, but thanks to this pair of 1 3s we know that this can't be either of those, so it has to be the 2 4 and this has to be the 1 3. 4 and 1 being one option, 2 and 3 being another. Similarly, what can we say here? This now is a 7, and it can't contain a 1 or a 3. So one option is 2 5, but is that the only option? Yes, because we can't have 1 6 and we can't have 3 4 to make 7. 2 and 5 is the only pair which will make it. Anything bigger is too big. Suddenly, we've already placed a 2 in this row, and that can't be a 4. So we have our first digits. And folding that out, we get a nice confetti. A little early for confetti. We've not done it yet, but the thought is appreciated. All right. So in this row here, we can't have a 1 and a 3. The smallest numbers we can have are 2, 4, and then it goes to 5. We couldn't go as high as 6, because if we had a 6 here, the smallest this could be is a 2, and we're already at 8, so let's ignore 6 and upwards. 2, 4 and 5. If we had 2 and 4 placed, that would give us a subtotal of 6, and we'd need another 2 here. That would have us placing 2 2s in the same box, so that's illegal, so we'd need 2 and 5. And that makes this remaining digit a 1, which again on the other side satisfyingly places things more confetti. How much can one man take? Okay. This 9 can't contain a 1 anywhere. So it has to be 2 7, 3 6, or 4 5. This one can't be 2 3 or 5, so the options for this square are 4, 7 and 6, meaning this one is 5 3 2 in some order. Not remarkable, but it's something. What's next most constrained? Perhaps this. Yeah. 6 can't contain 1 and 3 because it's in the same box. It has to be 2 and 4. And we see this is a 4, so we can place them. That means this can't be 2 and this can't be 7. That's more like it. Okay. Let's look at this 5 for now. Can be either 1 4 or 2 3. No reason for it to be either or. Perhaps. I don't know where to go next. I'm torn. This can't contain 4 or a 1, so it can't be 8 and 1. It can't be 4 and 5. It can be 7 and 2. Can be 6 and 3, and it can not be 4 and 5. As we can see, this can't be 3, and it also can't be 2. Which means this can't be 6 or 7. We'll eliminate possibilities slowly. It'll all fall together. I hope. This high cage, we should have been looking here, really, is 17. It only has one possible construction. It's 9 and 8. So, with that being said, there's no more 9s and 8s in this box. This 10 can either be 7-3 or 6-4. 7-3 or 6-4. And whichever of 3 and 4 this pair uses, this will use the other. Okay. All fine so far, I suppose. Ooh. But between these both, 3 and 4 will be used up. That's curious. So if this was 6, this would have to be 4. And now this would have to be 3 and 2. And if this was 7, this would be 3. And this would have to be 1 and 4. So always 3 and 4 will be used up by these digits. So now we have to make an 8 without a 3, 4, 8 or a 9. It's not as constrained as I would have liked, actually. Well, 3, 4, 8 and 9. 4 couldn't go on anyway. 3 means it can't be 3, 5. 8 and 9 couldn't have gone on anyway either. Could still be 2, 6 or 1, 7. Let's write it in. Why not? We haven't placed a 5 anywhere in the central square, in the central box. 5 can't be in any of these adjacent squares. If it was, we would have put it there. We've labelled all the possibilities, so 5 has to go there. I suppose that's quite nice. That settles this. 3 and 6. That helps us a little bit here. We know this isn't a 3 and this isn't a 2. But it doesn't help us resolve things just yet. No. Okay. And what shall we do next? I'm just going to put in some pencil marks that a 15 can either be a 9, 6 or an 8 or 7. I don't know which one yet. As can this one be. Got a little more constraint though, because this can't be a 6, but it can be a 9 and that can be a 6. No guaranteed digit usage here. Perhaps we just go to the other cage where we can't use a 1. Neither of these can contain a 1, so we could have 2, 5, or we could have 4, 3. And I suppose this one's been staring us in the face the whole time, so I hope it's not this one that we're missing out on. Can be 2, 6. Yeah, it's not 1, 7, and it's not 3, 5. So it's 2 and 6, which means this can't contain a 2 now, because the 2 is filled on this row. Has to be a 3. You have to have a 6 here. That can no longer be a 6, which means this can no longer be a 9. Otherwise, you wouldn't get the 15 sum. And we've made a little bit of progress. 2 and 6. 2 is now forced into these 2 squares for the entire box, which means that cannot be a 2. which means that this has to be a 2 and this has to be a 5. This is progress. What's left up here? 7, 8, 9. Let's write it in. Well, there's not much to go off on that one, but we know 7s can't be there because you need 2 of them. 8 and 6 does work, and 9 and 5 does work though, so we can't really eliminate anything at all. I think this is a little restricted, but not really enough to get me going. Do we look here next? I suppose following on from the same kind of logic as before. Oh, well, we can't have 1, 2 or 3, we can't have, oh, this is all very restricted actually, forgive me. Let's rewind. This can't be 1, 2, I'm talking about this square now, this can't be 1, 2, 3, couldn't be 4 anyway, can't be 6, so it's 5 or 7, can't be 8 or 9, so 5 or 7, which means this has to be 1 or a 3, 1, and it's in the same box as a 3, so it can't be there, so it's 1 and 7, that's useful. This cannot now be 7, which means that this cannot now be 8, and we are getting somewhere. We've removed 7 as a possibility from the 10 cage, so it's not a 3 either, it's a 4, 6 pair, useful. Suddenly that means we cannot have a 4 or 6 anywhere here, which means it's 2 and 3 in that order. Cannot have a 2 here. The only way to make this an 8 is to eliminate the 6. And everything is in harmony once again. What do we have left? We need 3, which isn't going in any of these. It's going in one of, well, actually it's not going in here and it's not going in here, so we can place the 3 outright. It's not 4, it's not 6, it's not 7, not, well, it could be 8 or 9. So 5 is the other crucial digit, and 5 is in one of those 2 down here, so can't go there. That is a 5. This is an 8 or a 9, and we are off. I feel like I say that a lot, and we're not often off. One, 2, 3, 5, 6. So we've got 4 left over there somewhere. We've got 7, 8, 9 left over there somewhere in the box 1. It's nothing incredibly helpful. I'm a little bit upset. Right, well, there's definitely a 2 here, and there's definitely a 2 here. So both column 1 and 2 are accounted for, so there can't be a 2 up there. No room in the inn. And it sums to 7, which means you can't have a 5 anymore, so it's 4 and 3 in that order. And where are we putting a 9 in column 1? Let's ask ourselves that. Because it's not a 9 in the 8 cage or this 8 cage. If there's a 9 here, that would force this to be a 4, and that would be a second 4. So there's a 9 in one of these. I think I've seen that logic somewhere else on the board too. Can we use something similar? No, we can't. Okay. could do with another little cage. 2 and a 5, 2 and a 6. Suppose that's all reasonable. This 13, and what can it be? It can't be a 4 and a 9. Can be a 5 and an 8. Can be a 6 and a 7. Not really any restrictions on them. 5, 8, 6, 7. Yeah. Oh well. Ooh. Tell a lie. That can't be a 5. Which means that can't be an 8. Because there's a 2-5 pair again. As there has been this whole time. What are we missing in row 1? Column 5? It's not 6, 7, 8, is it? No. It's quite a lot. Could be 8, 9. And it could be 4 and other stuff. 4, 8, 9, is that it? I mean, we can say this 1 means we have to have a 1 of these two. Oh, well, that's a digit which we can claim as our own. 1 in this box can't be in either of these columns, and it can't be here because we'd need the 13 cage. So 1 is in these, making this pair of 1s push 1 into the bottom box over here, placing 1 here. Now 1s are almost good. Following 3s then, place a 3 here by Sudoku, and a 3 here. This fixes the 1s. No 7 there. Twos in this 8th box can't be here, it can't be here, it can't be there, and it can't be here for a 2-5 pair. If we were giving out an MVP awards for best structure in the Sudoku, that 2-5 pair would be winning this, hands down. It's saved our skin. What are we missing there? Let's just do some more Sudoku while I look. Ooh, okay, these two are 2, but this 2 pair is pushing it here. Where can 4 go in box 2? Because it can't go in any of these, and it can't go in a 14 square, so that places it. And that actually places it in this box as well. And here too. So all of our 4s are done. Oh no, they're not. I guess they are. Everything is resolving itself. This 9 means 6 is gone for the 15 cage. This 6 means 7 is gone. And we've got 2 options left there. This 7-8 pair was pointing at that 7-8 the whole time. I could have been resolved to be 6, 7, 8, 7. I said it. 8, 9 here. And this is a 9. Ooh. 2 and 6. We're so getting there. All we need is Sudoku now. Maybe this 14 will be a deciding piece. Well, what do we need? We need 6, 7, 8 and 9. So it's either, well, it's 6 and 8. Because 5 has just been placed. It's 6 and 8 and it's this way around. That's 9 and that's 7. That's what we like to see. We've got 7 and 9 to place in that row. It's going to go this way around. And the puzzle has revealed to me its deepest secrets. Cannot stay safe any longer. Seven and 8, 8 and 7. What a joy. Nine and 5. That is a 2. And that is a 7, 8. Alright, I suppose. 7 has to stay there. 8 could be either of those. Oh. But it can't, can it? Oh, but it can. Oh, but it can. Okay. 1, 2, 3, 4, 5, 6. Those are how the numbers go, actually, as far as I'm aware. But that's okay, if we've gone our way. And at long last, in a time of 21 minutes and 57 seconds, A Killer Teacher by Sudoku and Missing a Few Cards is complete.